And welcome back, and it is the Corbett 5 a day higher plus, and it is the 15th of March, and let's just jump straight to the first question. So what do we have here? Function f is such that f equals, give us a function, solve. Okay, fairly easy start today, isn't it? So in other words, I am saying that 4x minus 7 is equal to 17. Add 7 to both sides, it gives me 4x is equal to 24. Divide by 4, which means that x is equal to 6. Pretty quick start to today. I presume it's going to get harder. Next question, or actually continuation. Find f minus 1 of x. So two ways I can do this, because there's only one x here, is I can do the flow diagram method. So I multiply by 4 and take away 7. So therefore the opposite, f minus 1 of x, is going to be take my x and add 7 and then divide by 4. In other words, I'm going this way. And the other method, which is actually exactly the same method, just with a slightly different layout, is I write down that y equals 4x minus 7, and I rearrange to give me x in terms of y. Either way, two ways of doing it, same answer. Next question. The histogram shows how long it took the students in year 10 and 11 to solve a puzzle. 117 students took longer than 100 seconds to solve the puzzle. Calculate an estimate. Wow, okay, this looks pretty detailed. Let's have a go at this one. What do I have? I don't have a frequency density is my first note. So I'm going to make my own frequency density up and then kind of just hope it works. But I can't hope it works. I need to check it works. So I'm going to say 0, 10, 20, 30, 40. Which means I can then work out the areas of these graphs here. So this, well, let's label them. So I've got A, B, C, D, E, and F. Now, I have to say, this is not very easy to see, so I'm going to have to zoom in. I can't zoom in anymore, but I'm going to have to carefully check what I've got. So let's write out the frequency. So A is 20 times 5. So A is 20 times 5, which is 100. B is equal to 10 times 19, which is equal to 190. C is equal to 10 times 35, which is equal to 350. D is equal to 20 times 26, yeah, 20 times 26, which is equal to 520. And then I've got E is equal to, that's 30, isn't it? So equal to 30 times, what a question, 11, which is 330. And F is equal to 2 times 30. Let's do the same way around. So 30 times 2, which is 60. And if, or actually, let's leave that like that. What is it telling me? So it says 117 students took longer than 100 minutes. So 100 minutes is all these students here. So in other words, it's these students here. So if I add D and F up, so if I add these up, I get, what do I get? I get 390. But I want it, and this is going to be a really difficult factor, isn't it? So I want it to be 117. So my multiplier is to multiply by 117 over 390. So I'm just going to check my calculator. 117 over 390. Oh, it does simplify actually. It simplifies down to 3 over 10. That makes me feel a bit better that I've got a slightly sensible number. Then what does it want me to do? Because I haven't actually looked at that. I should have started with that, shouldn't I? Calculate an estimate of the number of students who took between 50 and 95 seconds. So I need, well, 50 is here, so I need half of these. So I'm going to write this down. So I need half of A, 95 here, right? So all of B, all of C, and 80 to 190. So that's going to be 3/4 of D. And we can work that out. So let's just do that. So thankfully, now I will say, I've done the thing that I tell all my students not to do, which I've dived into the question. I didn't read what the question wanted. I was lucky that I needed to work all these answers out. You don't always need to, but in this case I do. So half of A is 50, plus all of B is 190, plus all of C is 350, plus 3/4 of D, which is going to be 520 times 0.75, which is 390. And then if I add all these up, so 390 plus 350 plus 190 plus 50 is going to give me 980. But that's using my frequency density. Remember, I have a scale factor here of 3/10. So I'm going to take this number, I'm going to multiply this by 3/10, and that's going to give me 294 students. Wow, bit of a sanity check. I'll say a bit of a sanity check. I can't think of an easy way of checking it without just doing it all again. Okay, I'll stick with that. Looks okay to me. Difficult question. Scale factor made it harder. It depends where you come into this. If you watch my other videos, you will have seen me work out frequency density and check this a lot. And I do often say it may not be the case that your frequency density works out. This is one of those questions. So good question. Final question. The surface area of the cylinder. Right, I was very close to writing volume then. The surface area of the cylinder is equal to the surface area of the sphere. So it's a surface area question, not a volume question. Express H in terms of R. Now, is this intentional? I don't know, but I'm going to go with it anyway. My R here is actually R over 2. So the surface area of my cylinder is the two circles, which is going to be pi R over 2 squared times 2, because there's one on the top here and there's one on the bottom. So there's two circles, top and bottom. And then I'm going to add on the curved surface, which is the circumference, which is 2 pi R over 2 times by the height. So in other words, if I unwrap this, it's a rectangle. Think about taking a label off a can. And that's equal to 4 pi R squared, where R is R here, because that's the radius. Okay, let's do this carefully. So 2 pi R over 4. So I'm doing this one. So R over 2 squared is R squared over 4 divided times 2 is going to give me pi R squared over 2 plus 2 over 2 cancels, which is pi R H is equal to 4 pi R squared. What a question. Now, take away pi R squared from both sides. Well, I should tell you what I'm going to do. I'm going to cancel my pi's because I don't need those, do I? So I'm a different colour, see what I'm doing. So I don't need the pi's anymore. I'm going to take away R over 2, R squared over 2 from both sides, which is going to be RH is equal to, well, 8 minus 1 is 7, so it's going to be 7 over 2 R squared. R doesn't equal 0, which means I can say that H is equal to 7 over 2R, and that's it. That's what I need to do. Wow, what a question at the end. That started really easily, didn't it, with a very straightforward functions question. That histogram question was nasty, really not nice, and that final question was really horrible because it implies that R is radius, which is R, but it's not R because it's R over 2, so you have to be careful. As ever, let me know how you did. Did you spot it? Did you manage to miss the trap, or did you manage to fall into it? Which is not the point, it's just checking you've read the question carefully, but obviously it's better to do that now in the exam. Either way, like, subscribe, let me know how you've done down below, and I'll see you for the next one. Thanks all.